All right, good evening and welcome to the MP9 review session. So MP9 is actually, I think, one of the most important MPs of the entire semester, because this MP really has you think about a framework that you haven't, that you may have never worked with before. And it's a framework that allows you to scale almost infinitely because you can keep applying more and more cores to this data. So I'm going to go ahead and go to the MP9 description on the course website. So in lecture, we have talked about MapReduce, and MapReduce is an algorithm paradigm that allows you to take data, map it into key value pairs, and then reduce those key value pairs until you get just one result. And specifically, what you're going to do is you're going to write both the both the mapping logic and the reducing logic. And I've already provided for you everything else, all the framework that needs to be done to do the actual MapReduce itself. So if I take a look at the provided code that you have is you're going to have a MapReduce.py. I added some more documentation and comments. So that was the biggest diff you saw. So I kind of took a MapReduce framework that was available that does local MapReduce. So one thing I believe is don't reinvent the wheel, but give credit to those who invented the wheel in the first place. So I took this base code and added some changes to it so that we can work with this in dictionaries. And what this does is this is the MapReduce class, and you can look at this provided code, and all it simply does is it does mapping and then it does reducing. And what you're going to do is you're going to interact with the program. And in the MP description, I start us out by going through the countletters.py function. And what MapReduce does is it's going to take a file and convert that file to key value pairs. And it's going to do that through the mapping function. So the mapping function is going to, for the counting of the letters, is going to be a function that is going to take the string that you read in from each file and then count how many letters in each file and store that as a dictionary and return that dictionary back. And this is going to be done for every single different function that you need to complete. So we're right now focusing on count letters. So we want to count the total number of letters. And what we have is here I have in the MapReduce, I have the map function and the reduce function. The map function is from the map_letters.map. So if I go into my mappers folder, I found map letters, and here is my map function. So this function needs to take in a file name and return all of the letters in that file name. So I'm going to go ahead and just for running this, one thing I think is really useful is do print, and I'm going to say the file name. So I just want to see what file names are coming in when I call this function. So I always love to see how is this actually working. So I should have a map function that prints out the file name. So I'm going to go ahead and run Python and then do countletters.py. And that's actually needs one parameter. So here, countletters.py books, data books.txt. So the files it needs to read in, I need to give it to it. So I want it to read in everything in the data books *.txt. So if I look at data, look at books. So here is the Gutenberg Project's Alice in Wonderland text. So this is the entire text of Alice in Wonderland. We also have the entire text of Through the Looking Glass. We have the entire text of Moby Dick. And we have the entire text of Sherlock Holmes. So we have 4 entire books text that we're going to analyze. So if I run this program, I get an error. In a very unexpected way. So if I look at this error message, it's an error message. Let's do some real debugging. Line 23 in MapReduce. So MapReduce line 23. I'm sort of surprised at why I should have never even got here, but let's see, what did I do wrong? It's going into the reduce phase. It doesn't even have data yet. So let me see what I did wrong here, because it looks like it's not doing any mapping. So I'm going to see what I did wrong by going in and seeing which files. It seems like this files array is not having any files it's giving me. So I'm going to just print out files and see what's going on. This is happening to you as well, Kevin, on WSL. All right, so we're seeing debugging it live. So here I'm seeing that count letters, data, books. So I'm not getting anything in files. And, oh, let's see if I get anywhere. So these are type errors, which makes me, so I'm going to just get rid of all the typing. I tried to make this more convenient. So I'm going to just try and getting rid of this. I have a different version of Python on this computer than the computer I develop on. So this may be one of these things with doing new MPs. Okay, yeah, so it's purely a type problem. So I will update the release and get rid of these types. So it seems like the type hints that I gave had issues, because now that I have all of this fixed, this is working as expected. So apologies about that. I had it working and then the types have made things crazier. So now going back to where we started. So we started off with the idea that we are going to have mappers that are going to map out each individual file. So the only thing I've modified, I've now gotten back to our base code. I've just removed the type. So if you update the release tonight, you will get this updated thing without any of the type hints, so that Visual Studio Code will give you less kind of useful information, but it won't give you those errors. And I'll debug the types offline and figure out what's going on so that I can bring them back in the future. But the only thing I've modified is I've now said in my mapper, I've printed out the file name. So here we can see that when I run the Python command, what my mappers are going to give me is going to give me 4 different files. And in reality, what you're going to do is you're going to open up the files and count how many letters are in each file. And that's what you're going to need to do for the map function here, where you accumulate the letters in a dictionary. You can read a file with here. I've given you some sample code right here on how you'd be able to interact with the file. And there's 3 assumptions that you definitely want to be aware of. So the first one is, as you create mappers, they need to be in the mappers directory. So you should create new Python files in the mapper directory itself. So if I want to have a second mapper, I can have map word length is another mapper that I have written. So you can name it whatever you want. Just make sure you have the mappers in the mappers file, and then you would have a new map function just like this that you would go ahead and write in that file. So I am working on map letters though. And the other 2 assumptions is you should always count only, you should treat everything as lowercase letters. And if you need to delimit it, if you need to like count the length of a word, you should treat anything that's not a letter as a delimiter. So that means even things like IT'(S), the its word, that IT'(S), because the apostrophe is not a letter, we have 2 words there. We have the word IT and the word S. So those are the 2 different words. Kevin and Michael said there's people who have mentioned this on Discord. So yeah, I didn't see any CampusWire posts. I'm always trying to make sure I keep on CampusWire. And when I have some time, I always hop on Discord and see how things are going there. So I missed that post, but I'll check it out next time I'm on the Discord. So everything should be lowercase letters. We should always delimit on all non-letter characters. And the last thing is that for mappers that deal with non-data, so we have some graphs that you're going to work with at the very end of this MP. don't transform the graphs to lowercase letters. So only if it's a mapper that deals with text should you delimit it with non-alpha characters and only treat it as lowercase letters. So what a mapper is going to return is going to return a dictionary of the number of letters. So I'm going to leave it up to you to actually write the logic count in number of letters. I'm going to just go ahead and return I'm going to say that, let's say every single file just said hello. So it's all lowercase letters. So a result that you might return is that key H is going to have a count of 1 because there's one H in hello. There's one E in hello. There's two L's in hello. And there's one O in hello. So this function is simply going to basically be a no-op in that we are going to always return the same thing, no matter what the file name we gave is. So it's giving us 4 different file names because there's 4 books in there. And if we run this, I now see that I'm going to actually store this as a variable D, just to make it really clear. I'm going to print out D and then return D. And what we see here is that we have Alice in Wonderland returned hello. So they've all returned hello. And now what we need to do in phase 2 is we need to take all of these individual results because all of these individual files were analyzed in parallel. And you can see in the MapReduce code, we are parallelizing this. So we have a multi-threaded pool that we're running all the jobs in. So they're all running at the same time. They're all running in parallel. And then they're going to get reduced in parallel by combining 2 of them together. So here, if I look at this count letters function, the count letters function is using the reducer in reduce sum reduce, which I can find in the reducers folder, reduce sum. So if I go into the reducer folder, look at reduce sum, you can see right now, I called the 2 parameters left and right. So I can think if I have a left result, I have a right result, and I need to combine them into a total final result. So this one, I'm just combining 2 dictionaries and counting them together. So this one, I can really just say, I'm going to say 4 key in left. So I'm going to go through every key in the left dictionary. And if the key is in the right dictionary, then I can go ahead and say right at key plus equals left at key. So I'm adding so if it's already in the right dictionary, I need to add to the right dictionary whatever the value is in the left dictionary. Else, I'm going to say the right dictionary needs a new key, and that's going to be equal to the value that's in the left dictionary. And because I'm updating everything in the right dictionary, I'm going to go ahead and return the right dictionary. So all I'm doing is I'm going through every single key in the left dictionary, looking and seeing if it's already in the right dictionary. If it is, I simply add to its value since I'm just summing up the total count of letters. So if I have 1 H in the left-hand side and 1 H in the right-hand side, it's going to become a 2. And if I ever get the case where one of the right side doesn't have a key that's in the left side, I can just simply go ahead and set that key there. And then I can return the right dictionary. So that's a reduction of the left and the right dictionaries into the right dictionary. And then I'm going to go ahead and print out the right dictionary right before it returns, so we can see the dictionaries get accumulated together. So if I run this, I can see that what I get is so these first 4 things are going to be the reading in. I'm actually going to add even more printout so I can better understand what's going on. So I'm going to print out left and right, because I think making your printouts very clear if you're going to debug, understand what the program is doing. This is what I always do, is really understand what's provided here for me. So left and right, and then reduction. And actually Python is Python. So let me make these F strings so it'll actually compile. Because otherwise I need to cast them to strings. And I actually noticed a typo that I made up here. So this should be the right variable. All right, so now this should print out. Awesome. So let's look at what's going on here. So I've read in the 4 files. You can see that they're actually in different orders now. It really does prove that we're running things in parallel. So these functions are all running at the exact same time. And then here in the left, so I have a left that's hello and a right that's hello. And then the combination, the reduction, the combination of the left and the right is now I have a single dictionary that has 2242. So that makes sense. I took a left result. I took one result from one book, the other result from a second book. I combined them together and I have a summary that combines both of those books together now. I have another left and another right that is 1121. I combine those into 2242, and you can see the very last reduction is 2242 and 2242 into 4484. So at the very end, I sort these letters for you. And once I sort them, it then allows me to print them out. So I print out, I think the top 20 is what I did, just so that you can see an intermediate result. Let's see, yeah, I print out the top 20 for you. So you're going to see a summary of the dictionaries. So this is all you need to do. You need to have a map function for every single problem that's going to convert the file data into a dictionary. And that file data is going to be independent of all the other file data. And then you need a reduce function that's going to combine the different summaries together. And you're only allowed for each problem one map function and one reduce function. So you have to write a single function that can map all of the input for the particular problem into a dictionary, and then one reduce function. And this is MapReduce. And what you'll be able to find out is you're going to be able to find that you may not always need additional reducers. Like there may be multiple things that you're just counting up the keys together. So you might be able to reuse this reduce count for multiple different map reducers. So I have 5 problems that I've prepared for you that sort of increase in difficulty slowly. So the first one is simply counting the number of letters in the text. So you do that in countletters.py. Then you have the number of words in the text in countwords.py. Then you have the length of each word in the text. So how if the word's 4 letters long or 5 letters long or 6 letters long. Then you have count bigrams in text. So bigrams is a sequence of 2 words in a row. So if I go to count bigrams, you'll see that in the Taylor Swift data set, I have it apostrophe probably is. So the 2 words, remember any non-space or non-letter character is the delimiter. So the first word is it, second word is S. So that sequence of word, IT followed by S, appeared 11 times in the Taylor Swift lyrics. I am, it appears 10 times. Got A appears 9 times. M insane appears 7 times. We re 6 times. A long. So you see that these are sequences of 2 words. So if we say, so if I think of intro to computer systems, all of the different bigrams here is in lowercase, it's intro to is one of the bigrams, to computers is a second bigram, and the third bigram is computer systems. So that 4-word phrase ends up converting to 3 different bigrams. So that's the 4th puzzle that you have to solve. And the 5th puzzle you have to solve is the same problem that we went over in lecture. So in lecture, when I introduced MapReduce, you got to find your set of mutual friends in findmutualfriends.py. And that is the 5th problem. So you're going to write lots of different mappers, lots of different reducers to go ahead and combine the different problems that are increasingly difficult into a dictionary that can be reduced down to a final result. And I have provided for you the expected result for different example inputs. So if you run this with data/Taylor star.txt, this is the top of what you should output down at the bottom when you run this program. And I have that for everyone. So count letters. Here we use the books data set. This is number of letters. The most common letters E, then T, then A, then O, then I, then N. In the word length data set, it's how long the length of words are in the Taylor data set. So in the Taylor data set, most of her words are 4-letter words. In the Lincoln addresses data set, we counted the number of individual words. So the, of, to, and are the most used words by Abraham Lincoln. And in the graph data set, we have the graph DCB. So these are the mutual friends. So D and C has a mutual friend of, sorry, B and C has a mutual friend of D. So that is it. It's really just exploring the MapReduce paradigm and understanding that you have to convert a textual file into a map function, this map function, or via a map function. And the map function has to take the file in, read in the file, return a summary dictionary of the file to solve the problem that you're asking. And then 2 of those dictionaries are going to be sent into your reduce function. You need to combine these 2 dictionaries into one resultant dictionary. And that's it. Just do this 5 times and you have completed MP9. So any questions? Kevin, you're a little confused about the last part of the MP. Specifically, what part? What do you mean? What do you mean by the last part of the MP, though? So you're not sure how to map reduce the graph? I promise it's all stuff you learned in 173. Just look at the data and think about, like, draw out the data. If you're not sure, you can even look on. Yeah, so I'm going to update. I was talking to Nikhil at 4 o'clock today, and I'm going to update the graph problems so that you can read it in through 5 different files, because I think that's more, that may make it simpler to kind of think about each node as an individual object. I imagine that you would return an array of all the individual dictionaries that you combine, but I do think having them as 5 separate files may make it flow more like the rest of the MP. So I can update it so you have one file that just contains A, one file that just contains B, one file that just contains C, D, and E. And that way it can be very clear what the reducers do. So I can add that update when I get rid of the types so that I remove the type error that I caused on my own computer. So private message, you said you'd only be able to create one map function, one read for each problem. Does the last one. So I wasn't sure about doing it multiple times. So the very last one, so right now, so the only change that I think will clarify exactly how MapReduce works is right now, if I look into data and look into graphs, I have graph 0 that includes all of the nodes and edges in one file. And I think it will be a little more clear of how MapReduce works if I have like a graph 0 folder. And in graph 0, I have an a.text, a b.text, a c.text, should be new, a d.text, and an e.text. And in these different files, I can then have an A. I'm just going to have the A component of the graph. And B, I just have the B component of the graph. C just contains the C component of the graph. D just contains the D component of the graph. And then E just contains the E component of the graph. So that way, when we run that one, which we'll do with data graphs 0 *.text, you will end up with 5 different files that you read in. So you'll end up with a.text, b.text, c.text, d.text, e.text. So your map will get called 5 different times in the graph data set. And then you would return the dictionary that's appropriate to represent the edges A to B, for example. And that's actually going to then streamline it just like, and it lets you think like you have a very limited set of information. All right, that makes a lot of sense. Thank you. Awesome. For 5 is A, B, the tuple type. If tuples will print out that way, you can use a tuple. I honestly just made a string. The string should match our string. I don't actually know if tuples will print out that way, but if I look at find mutual friends, I literally did the first edge space second edge, but so there's no comma in between them. So just make sure your key is parenthesis first node. No, the key. So these are directed or potentially. It should, the format, the output format, however you represent it internally, the output format should ultimately be, it should match the output format provided. So that's going to be node 1 name space node 2 name with parentheses around the outside. Confused about the format, how we should store the key value pairs in part 5. The output is meant to be key 2 nodes and the output V, they're mutual friends. Then shouldn't the map function output KV pairs? So Kevin, that's going to be up for you to play around with and just like explore. Like, I think that if the ultimate output needs to be a mutual friend, then you can't really change the keys partway through. The maps, the summaries, the in summary has to be, you know what the format of the in summary has to be. You know the answer you want. And you know that that summary has to be sent from the map functions to the reduce functions. So you know exactly the setup of what your dictionary needs to look like. The question is just what you need to do when you see 2 of these dictionaries to reduce it into a single dictionary. So it's really kind of applying a bunch of theory knowledge and figure out what, if I have 2 subgraphs that have these edges, what is the reduction of those 2 subgraphs when I want to know mutual friends. So if we reduce 2 graphs that have no mutual friends together, then there's going to be no mutual friends. So it really is kind of a challenge to, it's just thinking about graphs. I think if you spend a little bit of time thinking about what can my map produce, what is my reduce output need to be, it takes some time, but it's a really, really fun problem. It's a different way to think about how you program data. So it's the only really super challenging function. So I don't want to give away the answer. Any other questions? Yeah, so audio from last week's lecture. Yeah, all we have is audio. Sort of confusing not having any video with it. I can upload the audio, but a lot of the audio is sort of like, we're talking about what's being drawn. which unfortunately we don't have. So while we can upload the, well, I can definitely upload the audio, I don't know how useful it would be. It just does take time. So if that's something that you'd like, I can try and get that done either tonight or tomorrow. All right. Any other questions?